This presentation was developed for Recent Innovation in Electrical Electronic and Communication Engineer Conference 2018. A special thanks for all colleagues, students, relatives, our conference team, which has collaborated with this project. This presentation was divided with the following subjects: about me, a brief about the author and his projects, introduction, an abstract about the project, keywords and studies objectives, literature review, presents the literature used during the studies, methods and materials, explain the methods and materials used for the project's development, results and discussion, a discussion about the results obtained with the project, and conclusion about the studies and application. The next step will be presented information about the author. Hello everyone, let me introduce myself. I will talk about my degree, studies, and projects involved in my life. My name is Dr. Antônio Carlos Bento from São Paulo, Brazil. I work with academic resources involving computing, information intelligent systems, robotics, networks, software engineer, health, and informatics. If you need to contact me, please use the following mail, acb01@hotmail.com. Thank you. I am Doctor in Cognitive Environment and Digital Design by Pontifícia Universidade Católica of São Paulo, Brazil. I am Master in Information System by Osasco University. I have Master Business and Administration degree in System and Information by Universidade of São Paulo. I have studies about computing, digital design, artificial intelligence, information intelligent systems, robotics, automation, wireless body network, educational systems. I am working about the projects involving network, IoT, robotic, systems, and health. In the next step, I will make an introduction about the project. The project has a title, IoT with NodeMCU12EE with MAX30100, an experimental survey with the pulse oximeter and heart rate sensor. With abstract, this study presents the results of an experimental survey on the application of the Internet of Things in the use and development of pulse oximeter and heart rate sensor device, presenting the coupling capacity as well as in the configuration for creating a visible solution, contributing as a reference for the development of new solutions for the monitoring and improvement of people's quality of life. Due to the constant growth in the creation of solutions using IoT, this work has a focus on presenting solutions that can attain a part of large projects, which can be considered for future studies. The results obtained with this study made possible the understanding for the construction of a prototype, which allows to attend realistically and apply it in a case of study. The following keywords were used during the studies: IoT, Internet of Things, a group of objects connected which is possible transfer and control operation remotely. MAX30100, a kind of routine sensor for monitoring activities from people as pulse, oxygen, and heart rate. Oximeter, analyze with the pulse and the blood pressure for the patient oxygen during the monitoring process. Sensor, different kinds of sensors are available in the market. After the studies, the MAX30100 was selected. Heart, the sensors are used for heart monitoring, notifying about different values which need to be controlled. Rate, values obtained with the studies and body monitoring during the project. Objectives. The main objective of this study is develop an experimental survey and demonstrate a real application with the Internet of Things and heart rate sensor for monitoring patient activities. The literature review will be presented in the next step. During the studies, we used three main subjects as IoT. For the Internet of Things studies, we used bibliography available at the Electronic Engineer database with the Explorer and Latin America database, where are available a large content about electronics and electrical studies. Developed by students and researchers, this is the main base for studies used for this project. Arduino. The Arduino is a kind of control device used for communication and transfer data with a different device for Internet of Things projects. It has a large content of information with libraries and technical documents. There are a lot of control devices for Internet of Things projects. Arduino was selected by our low cost and available in the national and international market. For this study, the NodeMCU12E was used in compared to Arduino because it has more resources available. Sensors. A lot of sensors are available in the market. With the evolution for different kinds of projects, is very fast for build new trends. In this way, the actual model MAX30100 was selected because it is a tiny sensor and have three kinds of resources available in one, as heart rate, pulse, and blood monitoring. Methods and materials. Method. The following methods were used during the development of this project. Understand the problem. The first step is identify the problem in any situation. The problem was classified as a personal necessity for creation of a solution for monitoring people remotely. Literature review. After understanding the problem, as literature review is necessary for understanding the actual studies about proposals and opportunities applied in the same situation. Look for possible solutions. After and during the literature review, it was possible to identify what exists in the market and in the scientific community about the theme of study. Were constructed prototypes for demonstrate a possible solution. Understand how to solve the problem. After comparisons and tests with the proposals, it was possible to understand what kind of the solution will contribute to fix the problem. Solve the problem. With the data and tests realized, it was possible to analyze and validate the results. The data allowed to identify the better solution with the prototypes. The following materials were used during the project development. NodeMCU12E, a controller device used for Internet of Things. In compared to Arduino Uno controller, this device has better capacity as processor, memory, and with Wi-Fi integrated. MAX30100, a kind of sensor for monitoring heart rate, pulse, and temperature. This sensor was selected after studies in comparison with another kind of sensors with the similar resources. Arduino IDE, used for the algorithm development, which will connect the device and read and send data for analysis. Another type of materials were used as wires, mini USB cable, a computer with Windows 10. The next steps will be present the results and discussions about the project. With the studies, it was possible to create the following results. The NodeMCU12E, connecting schema for the NodeMCU12E controller. MAX30100, connecting scheme for the sensor MAX30100 device. Integrated scheme. Connection scheme for NodeMCU12E with the MAX30100 sensors. MAX30100 working. The sensor MAX30100 in operation with the NodeMCU12E during data collection. After tests and studies with different devices, the final solution was to connect the NodeMCU12E with the MAX30100 sensor, using the schema model for monitoring and collecting data during a short period. After that, the data were analyzed and displayed with the Arduino IDE serial monitor. This algorithm was used during the project development. The algorithm used was studied and adapted for the project. It is an example available with the libraries installed with the Arduino IDE during the configuration process for the device. The complete algorithm explanation is available in the manuscript. This is the serial monitor with the results during the collecting data. The serial monitor with the data collection results during the monitor process. Was possible to verify the variance of values during the collection process, modifying the sensor position and pressure on the device. In the next steps, we will present the conclusion about the project. As conclusion, we have the use of the NodeMCUXMAX30100 device in conjunction with the MAX30100, despite the lack of information on the use of the NodeMCUXMAX30100, as there is a lot of content related to the Arduino Uno, has proved to be a great possibility for creating different types of projects. Hopes that the results of this study can contribute to the creation of new solutions as a base for the development of more complex models. With the growth of solutions for IoT, there are great opportunities for the creation of projects that can collaborate with human development, dealing with problems related to the elderly or people with special needs. As future projects, it intends to expand the possibilities, adapting the model to a more complete platform, allowing the visualization by graphics, or even in a remote environment, allowing a more effective monitoring, development adequate control at distance, avoid accidents, and allowing control situations that may lead to personal problems. In the next steps, will be available the reference used during the project. Thank you very much for your attention. If you have any question, please send me an email, acb01@hotmail.com.